Hi, and welcome to SB 721 and SB 326, the Exterior Elevated Element, or Triple E, inspection requirements. I'm Erica Reynolds, and I work for a building enclosure consulting firm called McInnes Chen Associates. And this presentation is going to talk about these two Senate bills and the requirements for each one and some of the differences. And this presentation is targeted towards the building inspectors, people who will be doing these inspections. So this is an AIA accredited presentation. And our learning objectives today is we're going to look at the causes of wood decay and deterioration. We're going to review the requirements and differences for SB 721 and SB 326. I'm going to discuss different methods of performing these investigations and then also look at some typical problematic conditions with E3s. So here's an outline of the presentation. We're first going to review what causes wood decay and deterioration. We're going to talk about the basics of the exterior elevated elements, or also what I call triple E's or E3s. We're going to talk about why we need to inspect and what led up to the passage of these two Senate bills. We're going to review the two Senate bills, 721 and 326, both looking at the requirements and the differences between the two. Then we're going to look at different means and methods of inspections. I'm going to show some examples of typical problematic conditions that I've seen on these E3s. And then we're going to review some design recommendations to anticipate these inspections going forward and conclude the presentation with any questions. So first, let's look at what causes wood decay and deterioration, and specifically what we're looking for during these E3 inspections. So there's really two things that can cause wood decay and deterioration. One is what's called dry rot, which is a fungal decay that results in the cracking and powdering of the wood and causes loss of structural capacity. And also wood pest infestation. The wood pests actually eat away at the wood members and cause a loss of cross-section and loss of structural capacity. So decay, dry rot, as it's less formally known, requires three different things to occur. It needs a food source, which is the wood itself. It needs water, and it needs fungal spores. So dry rot is actually a fungal infection that is eating away at the wood. And the main thing that really contributes to this is the presence of water. So when we're talking about E3s, those are specifically wood elements on the outside of the building. And fungal spores are in the air. They're pretty much everywhere and are blown with the wind. So the main thing that we can control and that we can look for is the presence of water and moisture. And really what it is regular and long-term exposure to moisture that can lead to wood decay. So essentially the wood needs to get wet and not be able to dry out quickly. If you just have a wood fence that's exterior and it gets rained on but it's able to dry as soon as the sun comes out, then you're really not going to get dry rot and decay like you would in an enclosed condition. So what it comes down to is these E3s, they get water in through some kind of small opening or hole, and they do not have a good drying mechanism. So the water will stay for a long period of time and cause this fungal decay. And this is a fungus. So just because you can see and touch and see the soft wood and deterioration, that does not mean that is just the extent of the fungal decay. The guideline that my company uses and what we've talked about with different wood pathologists is that the fungus can possibly be penetrated into the wood 2 feet past what is a visible decay. So if you have, like in this diagram I show, if you have in the red a part of the wood that's visibly decayed and is soft wood when it's probed, you should assume that there's going to be a further penetration of that fungal infection into the wood, possibly up to 2 feet. So here's some examples of wood decay. You can actually see this kind of white fungus growth on the outside of the wood. And you can see around the fastener penetrations, we've got some of this black, which indicates corrosion of the fastener penetrations, which indicates moisture presence. We've got some flaking and cracking of the wood. And this part here is actually from pest infection as well. Here's an example where you can actually see mushrooms growing in the side of a wood panel on a balcony guardrail. And you can see that further past the mushrooms, we have cracking and delaminating of this wood panel. And here's another example. This is a balcony deck with a coating on top of it. And this portion of the deck was cut out, and you can see decay and deterioration within the plywood itself. So this is cracking and delaminating of the plies of the plywood. And also here's a photo of some paint peeling. This can be an indication that there's heavy moisture, so this is an area that also should be looked at for wood decay. So now let's talk about wood pest. There's lots of different types of wood pest. Main ones that we find here are termites and some boring beetles. They tend to be attracted to wet wood. And really, for these pest infections, they need to be inspected by a certified professional. The certified professional will be able to provide treatment options for this. But as inspectors, for the E3 inspectors, we can identify and look for some of the evidence that could indicate that there's a wood pest infection. So the evidence really is termite waste, which is also called frass, and what I call wavy paint. The termites like to get into the end grain of the wood, and they eat up through the end grain of the wood parallel to the wood. And so they'll eat underneath the paint a lot of times on the outside of the wood. And when they eat the wood and generate waste, it causes an expansion in volume, and it causes this kind of blistering that you can see in the paint. So I'll show some examples of that. And this is a map showing the presence of termites throughout the United States. And as you can see in California, and particularly along the coast, we have a very heavy presence of termites, and heavy to moderate up towards the more inland parts of California. So here's an example of the termite waste, the frass. It's these very, very tiny little pellets. They can range in color from very light colored to kind of darker color. And that really the color of it does depend on the wood that the termite's eating. But a lot of times you'll see these tiny little piles that indicate, this is where some of the waste has been deposited. So here's an example of a wood member, and here's a good example of some evidence of wood pest infestation. So we have these small boring type holes throughout the wood, and you can also see a blister or a bubble that I call wavy paint. Here's another good example of, we've got some boring holes over here, and we've got a lot of paint flaking. And to the left, you can see what's the wavy paint areas. So these could indicate that there is actually termites that have gotten into this member and have eaten along the end grain and have caused little pockets of waste to form underneath the paint. And here's an example from my own house, actually, where the termites got in and ate up the end grain of this roof eave. And from the outside, it looks fairly normal. But as soon as you start cutting away, you can see that they've completely eaten away at the cross section. And this is how it weakens the wood, by removing actual cross section of wood. So you're losing that structural capacity from your wood members. So now let's go into the basics of E3, particularly in the framing of the E3 elements and how that relates to inspection. So what areas should you be concerned about when you're looking at these different elements, and what areas should you be paying attention to on a structural basis? So there are several different framing techniques, and there's really a couple typical ones that we see for these exterior elevated elements. First is cantilever. So that is the element actually cantilevers out from the building. Second is simply supported, and that can be done in a multitude of ways. One could be possibly beam and post supported. exterior elevated elements, or ledger and beam supported elevated elements. And we also see quite a lot of cantilever and simply supported. So this is framed by cantilevering out from the building and then either a beam and post type support on the free end of the cantilever. So here's an example of cantilever. You can see that these joists extend back into the building and they're supporting this wood framed balcony. One thing to note with the cantilever, typically to achieve this support condition at this end, this cantilever is actually twice as long of a joist into the building. So say if this joist extends out 5 feet, there's typically 10 feet of joists that run back into the building. So this joist is a total of 15 feet long. And when looking at the loading diagram on a cantilever, this is just a typical for a uniform distributed load on a cantilever beam. You can see that our max shear happens where the beam enters the building, so right at the support point at the building. And our max moment also happens at that point. So when looking at this from an E3 inspection type, we're concerned mainly with the structural capacity of the framing as it enters the building. If we have significant decay and deterioration where the beam enters the building at this point, we could have a very problematic condition, because that is where the highest load and the highest moment is happening within the beam. The next one is simply supported. So you can see here there's 2 beams that are running, framing this, and all of the joists are simply supported between the 2 beams. They're hung with joist hangers off of these. And when looking at a uniformly distributed load on the load diagram, the maximum shear is happening at the supports and the maximum moment is happening in the middle. So when you're looking at this type of framing, you should be concerned with where the supports are occurring, where the high shear loads are occurring, and where the moment occurs in the middle of the beam. One thing to note too is in terms of structural, right adjacent to where the support is, that's the concerned area, because your support is holding up this max shear here, but just to the left of it, just where the support ends, that's where you could have a catastrophic failure. And then lastly, let's look at cantilever and simply supported. So you can see that these beams extend back into the building. This is just some blocking that's installed between the beams, probably to carry the edge condition of the decking above. And the free end, what I'm calling the free end, is supported by a beam and post situation. And so when looking at the support and loading diagram for that, it's a little bit more complex. We have shear locations at the supports. We have high moment at the where the cantilever beam enters the building, but we also have a high moment in the middle of the span, and we also have a shear at the end, the free end of the cantilever. So essentially, the more supports you have, the more complicated the structural framing is, the more areas you need to be concerned about when you're looking at the inspecting it from an E3 inspection point of view. The higher the amount of supports, you have an increase in redundancy. So in a cantilever situation, if you have cantilever joists fail, you have less redundancy to help keep the E3 element from collapsing. When you have multiple supports, things like simply supported or the cantilever and simply supported type situation, you have a lower chance of an extreme catastrophic failure because you have more redundancy in your support system. Typically, when it comes to different types of failures, shear failure is considered more catastrophic. There's usually less of a warning provided on that. And a bending failure typically provides some type of warning before a catastrophic failure. So that means like extreme deflection in your joist, sagging, that kind of thing. So usually the bending failure is less catastrophic because you can see, you get a warning system, you can see it happening before you get an extreme failure. So let's look at the different railings. These railings are also included in your E3 inspections, which we'll talk about a little bit more about later. And they are considered part of the life safety. So a lot of times people lean on these railings. They're meant to prevent people from falling off of these balconies. So these are also very critical areas that need to be inspected as part of the E3 inspection. So there's really two different kinds of framing for a railing system. There's the fascia supported or face mounted railing, where it's secured through the face of the balcony or the E3 element. And so here's an example of a detail. And if we look at the loading on this and you push at the very top of the railing, it causes a moment down at the anchor points. And a moment also is considered a couple force, or it's a coupling force. So it results in a tension and compression force within the anchor of this framing. So when you're looking at and considering where would the structural concern be on this balcony, you really want to look at these anchor supports here and the wood framing members that are connected to these supports. So if any of these wood framing or any of these anchor systems have some kind of decay and deterioration, that should be noted as a concern that needs to be addressed at some point. And again, let's look at a top supported railing. This is the other style. Typically, this is done through base plates and individual post or a shoe type railing system, and it's secured through the top walking surface of the deck. So structurally, when we look at this and we're pushing that balcony over, it creates a moment down at the base, which results in a compression and tension force within the anchors itself. So again, we need to look at these anchor bolts and at the surrounding wood members that are supporting this railing to see if there's any decay or deterioration when looking at this. One other item I want to note is that when we're looking at guardrails, we also need to look at the panels in the guardrails. So between the framing support post, the panels are there to prevent people, again, from falling off a balcony or going through a balcony. So those also should be structurally sound when we're doing these inspections. So looking at the E3 typical framing, there's decking, which can consist of a lot of different types. There's either 1x2 wood decking, composite decking, which is still wood-based, plywood sheathing with a waterproofing layer and a concrete topping. Sometimes also I've seen tile topping, and plywood sheathing with traffic coating directly on the plywood sheathing. Supporting members can vary as well. They're typically around 2x or 4x joist or 4x, 6x beams and ledger type situation. There could be post, 4x or 6x wood post with a concrete post-based foundation, or they could also be steel post. Those are not required as part of the SB 721 and SB 326 because they're steel. So we'll get a little bit into that when we're talking about the different Senate bill requirements. Rim joist, a lot of time are in part of this. Fascia, blocking. If you're looking at stairs, you can have stair stringers, which could be 2x wood framing, and risers and treads, which could be 1x or 2x woods. Guardrail can consist of a lot of different types. Wood framing with post and panels, wood framing with post and spindles. You could have a completely metal railing, glass railing, and fascia mounted or top mounted typically is the framing part. There's lots of different connectors, joist hangers, nails, lag screws, bolts, etc. And here's kind of a good diagram that shows all the different types. As you can see, this guardrail is fascia or face-mounted guardrail. It's a post and beam type framing situation with post base, foundation. Oop. This is the ledger in the back here where the joists are hung off of. So that's the basics of framing and kind of the structural basics of how these E3 work. So now we're going to go into why we need to do these inspections. So in June 16th, 2015, there was the Berkeley balcony collapse. This is a very famous incident that happened. It was a party at an apartment near UC Berkeley. the third floor balcony collapsed onto the second floor balcony and several people fell to their deaths. 6 people died and 7 were injured. So here's a very famous photo. This was all over the national news. And you can see the joists that were supporting the balcony have completely sheared, and this has now flipped over onto the second floor balcony here. And wood decay was found to be a contributing factor to this collapse, and it resulted in several different actions, along with some other failures, pretty significant failures that occurred. But the first thing was the City of Berkeley enacted an ordinance for E3 inspections. There were new building code requirements for new construction that was enacted in the 2017 emergency addendum and is now fully part of the 2019 California Building Code. And it resulted in the passage of Senate Bill 721 and Senate Bill 326. So let's briefly look at what the new code requirements are for new construction. So it requires details and manufacturer installations for waterproofing for the weather-exposed balconies and walking surfaces to be submitted to the building department. It also requires either a building official inspection or a special inspection for the waterproofing portion of weather-exposed balconies. And the municipalities can either include it as part of the building inspector's job or require special inspections. And we have actually seen some municipalities enact special inspections. And those special inspections are required under Section 1705.1.1, Item 3, which requires materials and systems to be installed in accordance with manufacturer's instructions that prescribe requirements not contained in this code. It now requires venting in enclosed soffits underneath balconies and exterior elevated walking surfaces. And it increases the structural live load requirements for balconies and decks to 1.5 times what the area that's served, not to exceed 100 PSF. So, for example, a residential multifamily private room has a live load of 40 PSF. A balcony off of that private room would therefore be required to have a 60 PSF live load. So this is a 50% increase from the 2016 California Building Code. And finally, it resulted in SB 721 and SB 326. So these are 2 Senate bills that were passed to require regular inspections of exterior elevated elements. First, we're going to go into some definitions. So what is an exterior elevated element? This includes balconies, decks, porches, stairways, walkways, and entry structures that extend beyond the exterior walls of the building, has a walking surface that is elevated more than 6 feet above ground level, is designed for human occupancy, and it relies on wood or wood-based products for structural support. Railings and guardrails are also included in these E3 elements, even if they are not wood-based. So if you have a metal guardrail on a wood-based exterior elevated element, then that is considered part of the Triple E. And then what are load-bearing components? These are components that extend beyond the exterior walls of the building to deliver structural loads from the E3 to the building. So that's all the structural framing that holds up these E3s. And associated waterproofing elements is defined as items that protect load-bearing components of the Triple E from exposure to water in the elements. So this is flashing, membranes, coatings, sealants, etc. So first, let's look at Senate Bill 721. So this was passed in 2018, and it requires inspection of Triple E's of multifamily residential buildings with 3 or more units. This excludes common interest developments, so condos and co-ops, etc., are excluded from the SB 721. And as a direct quote from the bill, the purpose of inspection is to determine if the Triple E's are generally in safe condition, adequate working order, free from any hazardous condition caused by fungus, deterioration, decay, or improper alteration to the extent that the life, limb, health, property, safety, or welfare of the public or occupants. So that is the main purpose of this bill. It requires a minimum of 15% of the load-bearing components and associated waterproofing elements to be inspected on a building of the E3s, The report is due to the owner within 45 days, and the owner is to keep a copy of that report for 2 inspection cycles. And this should be noted that the report timeline does not matter how many E3 elements are inspected. If you inspect 3 balconies or 300 balconies, you still need to give the report to the owner within 45 days. If the inspection report indicates that one or any of the triple E's pose an immediate hazard, then you need to submit that immediate hazard report to the building owner within 15 days, and you also need to notify the authority having jurisdiction. These inspections can be performed by a licensed architect in the state of California, a licensed engineer from the state of California, a licensed contractor with an A, B, or C5 license with a minimum of 5 years experience, or a certified building inspector. The inspections need to occur every 6 years, so this is an ongoing maintenance item that building owners need to do. And the first inspection needs to occur by January 1st, 2025. And the inspection entails a quote-unquote visual inspection of load-bearing components and associated waterproofing elements of the E3s. The report needs to include the following. Identify each of the load-bearing components, so a diagram of the structural framing is a good idea. It needs to say what the current condition of the triple E is, expectations of future performance and projected service life, recommendation of any further inspections, and it also needs to be stamped and signed by the inspector. It also needs to include photographs, test results if you do any kind of testing on these elements, and a narrative of what was observed and what was inspected. And if any of the triple E's pose an immediate threat to the safety of the occupants, the inspector in the report needs to indicate whether restricting access or temporary shoring is necessary. Following these reports, if there's any immediate hazards noted, then the owner needs to immediately start repairs or actions to limit access to that triple E. Any corrective work identified in the report needs to be completed within 120 days of an approved permit. If the owner is not compliant within 180 days, there are fees that can be implemented by the building department. If a residential building is sold or converted to condominiums, the SB 721 inspection needs to happen before escrow closes. And for buildings that were built after January 1st, 2020, then the first inspection needs to occur within 6 years of the certificate of occupancy. So this is something to note too. The age of the building does not matter for 721. Even brand new buildings are going to have to require these regular inspections to occur. So now let's look at 326. And 326 was passed to close the gap that 721 included with respect to condos and common interest developments. So 326 is the same E3 inspection requirement for common interest developments. So this was passed in 2019. And again, it's inspection of the triple E's of multifamily residential with 3 or more units. So if you have a duplex, not considered part of this requirement. Again, the purpose of the inspection is to determine if the triple E is generally in safe condition, adequate working order, and free from any hazardous conditions caused by fungus, deterioration, decay, or improper alteration. A little bit different. So the amount that needs to be inspected is a randomly statistically significant amount. So that means the amount that can provide 95% confidence with a margin of error or plus or minus 5%. So this Senate bill leaves it up to the inspector to determine how much needs to be inspected as part of their professional judgment to provide 95% confidence. The report is due to the owner. However, there's no timeline given, and the owner is still to keep a copy of the report for 2 inspection cycles. And by owner, I apologize, I mean HOA or board. If an inspection report indicates the triple E poses immediate hazard, you need to immediately notify the owner and notify the building department within 15 days. These inspections can be provided by a licensed architect and a licensed engineer in the state of California. The inspection cycle is every 9 years, and the first inspection is to occur by January 1st, 2025. And again, it's a visual, quote unquote, visual inspection of load-bearing components and associated waterproofing elements. And the report requirements are the same as for 721. And again, if any triple E's pose an immediate threat to the safety of the occupants, the inspector or the report writer needs to indicate whether restricting access or shoring is necessary. Following the report, immediate repairs or actions need to happen immediately to address the hazardous conditions, so the immediate threat to life safety conditions. For condominiums with a certificate of occupancy after January 1st, 2020, the first inspection has to occur within 6 years of the certificate of occupancy. So like 721, 326 does not matter the age of the building. Brand new buildings will also need to follow this inspection requirements. So let's look at the main differences between 721 and 326. 721 is for, it's multifamily residential of 3 or more units, excluding common interest developments, excluding condos. A lot more people qualify as inspectors under 721. You could be an architect or engineer or a GC or certified building inspector. The cycle's a little bit quicker, of 6 years, and there are timelines of when the report's due to the owner and when the owner is required to make repairs. And it also requires a 15% minimum inspection. 326 is specifically for condominiums and common interest developments. It limits the inspectors, the people who are qualified to be inspectors, to just architects and engineers. The inspection cycle is every 9 years. There's really no time limit unless there's an immediate threat identified. And the amount of inspection is really left up to the professional judgment that will provide a 95% confidence with plus or minus 5% margin of error. So essentially you have to be a statistician to determine how much of the E3s you need to inspect. One thing to note for both 721 and 326 is if problematic conditions are observed, then you are required to do additional inspections. The amount additional is left up to the professional. So if you inspect 100 balconies and 50 of them have problematic conditions, you as the professional need to determine how many more you want to inspect. It could be you now require full inspection. It could be now you only need to see an additional 2 or 3. It is left up to your professional judgment. So now let's look at some different examples as to what constitutes a triple E. So looking at this photo, we have a couple balconies that extend out past the building, and this post has been highlighted in red. So this post is considered part of the triple E because it is supporting these 2 balconies above. And then let's look at this particular guardrail. This is also considered a triple E because it is part of this triple E element here. And this post here is not considered part of the triple E because it is supporting the roof eave framing above. It is not supporting this balcony here. You could argue if this parapet here is secured to this post, then you want to look at this post because it is part of the framing of this guardrail element here. This is a stairwell back here, and this is a wood framed landing within the stairwell, so that is also part of triple E. This roof eave that extends horizontally past is not an E3 because it does not have a walking surface on it. Here's another stairwell on a wood-framed building, but the stairs are a metal stair stringer and concrete treads. So the landing is a wood-framed element that extends past the building. This is part of an E3. This is part of that needs to be inspected. This stair right here is not part of that because it is metal, steel stringer, and concrete treads and metal guardrail. So this is not considered part of the E3. And then this is a wood frame balcony that extends past a building, but it is not considered an E3 because it is less than 6 feet above the ground. And really that 6 feet comes from, is it going to cause serious injury or possibly death if somebody were to fall off of one of these balconies. And here's a great diagram. This is from the City of Berkeley E3 inspection program. So this diagram shows that these elements, these balconies and guardrails that are extended out are part of the E3. Same thing with this stairway here. You can see here this stairway is not because it's indicated as less than 6 feet. And then also something to note, these roof decks that are over occupied space are not part of the E3 requirements. One thing to note that's different about the City of Berkeley is that they also include steel framing within their E3s, whereas the 2 Senate bills are purely for wood framed or wood-based products. So a couple tips when proposing inspection work and keeping your owners informed and your clients informed. I would inform the owner that you're going to need access to both the top and the underside of the triple E's. So you need to look at both the framing of the balconies and the exterior walking elements, and also look at the decking and the guardrails on top as well. So typically that means you're going to need access to the underside, and you're possibly going to need access through units in order to get to the top side of these decks. You may need to perform DT to review the load-bearing components. So if you have an enclosed soffit, the only way that you're going to see the load-bearing components is if you actually get in there. So that it's going to require opening up some of these areas. And just keep in mind too, if this this has to happen on a 6 or 9 year cycle. So you're going to need to do these DTs every 6 or 9 years, depending on the construction you have. One thing to note too, when performing due diligence or property condition assessment, inform the owners of the building that it's going to require regular inspection based on the 6 or 9 year cycle because of these Senate bills. You also want to indicate to the owner of the HOA that they may need to carry a budget to perform immediate or emergency repairs. So as soon as you do this inspection and you indicate that there is an immediate hazard to the life and safety of the people in the building, the owner has to immediately begin working on it. So that could be restricting access to the units, providing shoring, and then they have to start immediately working on a repair schedule. So they need to not only carry the budget for the inspections, but understand that there's likely going to be some repairs that happen. I would also request the wood pest inspection records from the owner. If the owner has been doing regular wood pest inspections, then I think it's reasonable to assume that you're only going to need the 15% minimum requirement for inspection. The wood pest inspectors catch a lot of these issues. They catch a lot of the wood pest and also dry rot issues that happen on a building. If the owners of the HOA have not kept up a regular maintenance schedule of doing pest inspections, then I think based off of the amount of termites that we have in California, it is likely that you're going to find problematic conditions. You are likely going to find pest infestations and possibly dry rot within the wood elements. I went to a wood framed construction seminar a couple years ago, and there was a wood pest expert there, and he recommended getting an inspection every year. And so at my personal house, I have started getting a termite inspection every single year. And every year there are termites that need to be treated. It's just a constant issue that we have to deal with in California. So now let's go into the means and methods of doing these inspections. So number one question I get on these inspections are, particularly if you have an enclosed soffit. Do we need to probe and do we need to do destructive testing in order to remove the soffit to physically probe the structural members? There are people out there and there are companies that say that they can basically drill a small hole and use a borescope to look at the framing. And technically, the Senate bill does say it's a visual inspection. However, I'm going to give some examples as to why I think you need to probe. Probing uses a sharp tool like shown down here. You can also use something like a flathead screwdriver, even sometimes a pen or keys if you're really desperate, if you're looking at something. And what it is to check for soft wood that indicates decay. It's also a good way to find evidence of wood pest because a lot of times when I probe that wavy paint, you have wood pest waste that comes out and you can easily indicate that there's some wood pest infestation. What I did is I zip tied a probe to the end of a broom handle in order to be able to get underneath the balcony and probe from underneath. This saves on a ladder, needing a ladder to bring everywhere. It's a little bit safer not having to climb ladders, and it works pretty well and to make your inspection go a little bit faster. I will note too, if you're going to be doing probing, I definitely recommend eye protection because if you probe a wood member and you get wood termite pellets falling out, I've learned from experience that they can get into your eyes. So why do we probe? So if you look at this photo here, this photo was provided by Tracy Myers of Myers Consulting. Thank you to her. This is a cantilever wood joist. And if you ignore these previous probes that happened and you look at this joist, it looks like it's in pretty pristine condition. Just visually, I don't see any issues really with it. But as you can see, this is a probe that's inserted 4 to 6 inches into this wood. That is how much this joist has now decayed, is that we are able to get that soft of wood. So just visually looking at something, you're not really going to be able to tell the condition of that wood unless you probe. So then I also recommend checking the guardrail. This is very important as the guardrail provides a life safety measure. First, I shake the guardrail, see if it's loose. If it's loose, you can pretty much guarantee that either the connections, the anchor bolts, are deteriorated or the wood that's holding the anchor bolts is soft and deteriorated as well. If the wood surrounding the anchor bolts has lost some of its structural capacity, your anchor bolts now do not have solid wood to grip onto. So your guardrail will be loose. Also check for the guardrail panels. As I mentioned before, panels are there to provide a structural barrier so that people can't fall off or things can't fall off these balconies. Check for soft spots in the decking. So when you walk around, feel for soft spots and bounciness within the decking itself. If you have a plywood sheathing with a traffic coating, look for cracks and seams within that traffic coating and then the plywood, as those are the first areas that generally will fail and cause water to be able to get in. If your balcony slopes to some kind of area drain or, if it's supposed to slope to drain, sheet drain off the edge, check for sloping, because if you have water that's ponding on your balcony in specific areas, that could indicate that one, you have decay in your framing underneath that has now settled and allowed for ponding to happen, or two, it was built that way and now you have water buildup in specific areas that could lead to decay and deterioration. 90% of leaks occur from 10% of the waterproofing. So that really talks about how most leaks occur around the perimeter conditions and around penetrations. Pay special attention to seams and sheet metal flashing. Sheet metal flashing is used a lot in these balconies as either perimeter flashing, saddle flashing, drip edge flashing. And while the sheet metal itself is waterproof, things can't get through the sheet metal, the seams generally are not treated very well or constructed very well. And when the seams start to pull apart, that's how water can get in and underneath sheet metal flashing. And since sheet metal flashing is so waterproof, it can keep water in there for long periods of time and lead to the decay that we see. Look for things that are small gaps that can trap water or debris. These small gaps are very pernicious because they allow water in, but it's hard to get water out once you've got it into these small gaps. As I mentioned, pay special attention to the edge conditions and any penetrations. And then finally, pay attention to cut ends of wood members. So dry rot and termite infestation typically gets into the end grain of the wood. So if you have a cantilever joist, typically the decay and the termites start at the end of the joist, the free end of the joist, and work their way through. So let's look at some examples of problematic conditions. Here's an example of soft decking. So this is again a probe that completely went through the decking here. This particular area was an area of concern because everything on this balcony sloped to this area, and you can see lots of debris that have gotten caught in the end pieces here. And one note on debris and leaves. One, they attract bugs. And two, it easily traps water. So all of these leaves and dirt can get wet and sit there wet for long periods of time against the wood. Here's a balcony. Here's an example of the panels. So there's support posts that are supporting the balcony guardrail and then panels. And this panel, actually the little kick plate or the end trim on the panel was loose. And so all of these panel boards were loose as well. So that's something that could potentially be a hazard. Here's an example of what termites can do. So they get into the end and they just eat their way through the joist here. This particular balcony was retrofitted at one point and supported by posts and beams. But then the balcony above is also completely destroyed by termites, and there really is no post and beam support on this balcony above. Here's an example of the wavy paint, an indication of termites. So when I probed this, I had a lot of wood termite pellets that came out. Here's another example of when you have a post and beam framing situation. We have this post, and you also should check the connection to either the foundation or the post base down here. So while this post was in good condition, this foundation is completely cracked and essentially failed completely. So this is a repair item that the owner needs to do. Here's another example of dirt and debris being trapped in a small area that can cause some decay. And then this is actually a probe into the joist below showing that there is some decay. So in terms of details, there's specific areas that tend to be problematic. One is drip edges, particularly when we have a traffic coating on top of plywood sheathing, drip edges. So what happens is right where the sheet metal flashing ends, this joint here within the traffic coating tends to be a weak point. This drip edge heats up from the sun and can expand. It has differential movement between the plywood and the drip edge, and it can generally cause a crack right along the seam and allow water in. One other thing is the overlap seams in the drip edge. So this is sheet metal drip edge flashing. This is the walking surface. And here's a fairly large gap between this side of the drip flashing and this side that water could get into. And, from just looking above and not having the actual plans, it's unclear whether or not this sheet metal flashing is set in sealant over some type of waterproofing membrane. We just don't know. It could be just directly over the plywood and allowing water to get in. Another drip edge, these are sometimes the stop edges for concrete topping, and a lot of times they have weep holes within them to allow any drainage that gets underneath out. The only issue that we see is that these weep holes, either one, need to be perfectly located so that they're right where the drainage matrix is, or they also get filled with concrete and blocked. And once your weep holes are now blocked, you can have a buildup of water within your system, and that buildup tends to find the next weakest point. So you could have, a small crack or penetration somewhere in your system that can allow water in because we have this buildup and it is not able to easily drain. Another area that tends to be problematic is top-mounted guardrails. So, these are a lot of sharp transition edges that happen, and you can have a lot of differential movement and expansion-contraction movement between your balcony guard railing and your adjacent wood members. So here's some example. These are areas that should be paid particularly close attention to when you're doing E3 inspections, because these are types of areas that can tend to fail and allow water to penetrate. Another area is door thresholds. So again, it is because of sheet metal flashing. So this is a sill pan that extends out and the traffic coating extends onto the sheet metal. This is a weak area that'll fail at one point throughout the age of the building and could allow water to come in. And same thing with wall-based flashings. A lot of times these wall-based flashings are sheet metal L angles, and we can have a weak point right where the sheet metal L angle transitions to the plywood. We can also have a weak point if the wall waterproofing is not adequate. I have seen locations where this wall-based flashing is completely deteriorated because of water from above, and so now we have a very vulnerable spot right at this transition. Saddle flashing is another one, or lack thereof saddle flashing. So looking at this balcony edge here, we have the drip flashing that just finishes right at this edge here. And so now we have a vulnerable hole there and another one from above. And you can actually see in this photo too that someone had applied sealant at some point to this edge. Usually if you see kind of sealant globbed on like that, that's an indication that they've had issues there and they're trying to deal with it at some point. So now finally, let's talk a little bit about design recommendations. So these design recommendations are not based off of weatherproofing or waterproofing. You do want to have good weatherproofing and waterproofing to protect your balcony and protect your wood framing. These design recommendations are purely based off of the anticipation of having to do these inspections on a regular basis. Two of the biggest things that I see that are a hindrance to us doing these inspections are, one, enclosed soffits and the type of framing, structural framing that's used. It makes it sometimes very difficult to either inspect or to make repairs on something. So one design recommendation is to consider not doing an enclosed soffit anymore, to just use open framing. If you do an enclosed soffit, you have to expect that you're going to need to do DT on that enclosed soffit on a regular 6 to 9 year basis in order to do these inspections. The issue with that is there's some fireproofing requirements. So for exterior walking surfaces, they need to be fire protected. One way to do that is automatic sprinklers, or to limit your building to the type 5B building type. Next is to avoid cantilever framing. So as I mentioned before, the cantilever joists that stick out, they extend back, typically they extend back into the building. So if you have any serious decay or deterioration on your cantilever, you now have to open up inside your building in order to do a full replacement or some type of serious repairs on that cantilever framing. If you use simply supported by doing a post and beam type framing situation, it is far, far easier to replace severely deteriorated framing members. So if you have a simply supported joist, usually you can just shore up that balcony and remove that simply supported joist and then put a new joist and hang it between the two support systems. So I'd recommend designing your framing to be ledgers or post and beam and simply supported over cantilever, just to assume that at some point you're going to have to do repairs on these wood members because of dry rot or termite decay or something, and it's going to be far easier to repair damaged wood members. One other thing to avoid having to do these inspections altogether is to no longer do any kind of exterior elevated elements and just make everything a roof deck over occupied space. There is a problem with that because now you've increased the risk on those systems. By having a roof over occupied space, you now have a much higher risk of waterproofing damage to the interior because you are now over occupied space. So that is just a risk trade-off that you need to consider during your design. If you have to use enclosed soffits, I'd recommend installing access panels. And these access panels need to be large enough to allow probing to happen on your joist. Another thing you could do is avoid wood or wood-based framing altogether and just use concrete or metal framing. There might be also some fireproofing requirements that are needed for the metal framing. And then the last thing is just a good maintenance item for building owners to do is to do regular termite and wood pest inspections. That way you can catch some of these wood pest infestations early, and generally the repairs for that are much, much faster and easier to do. So to conclude, E3 inspections are going to become a large part of the building enclosure and architecture and engineering work. This may begin to extend into other areas of the construction world. If we have more failures, let's say, of a roof deck, this might now be part of that. The roof decks might become included in part of this inspection as well. So just consider that this is something that could potentially get bigger and bigger and bigger. It's distinguished between whether or not you need to do 721 inspections or 326, as there are some differences that can be pretty significant. And then finally, the bills rely heavily on your own professional judgment. So you as the inspector need to sign and stamp these reports. And so you need to use your professional judgment. What are you comfortable with for the owner to understand? So going back to the question of whether or not a borescope is adequate or if you need to probe, me as a professional, I would require that we need to probe, because I've seen enough issues where visually something looks fine and it could be significantly deteriorated that you just can't see, and you can only indicate through probing. So if I'm going to sign and stamp a report, I'm going to require that we do some type of probing. So it does rely heavily on that. There are some liability protections, as this is just supposed to be a quote-unquote visual inspection, and it's not supposed to be an exhaustive inspection, and you're not supposed to really be coming up with repair recommendations right then and there. But, just use your professional judgment. What are you comfortable with on these? So I just want to say thank you and open it up to any questions. And thank you very much again.